So Doug is the Regional Operations Supervisor for U.S. National Oceanic and Atmospheric Administration's Emergency Response Division in the Office of Response and Restoration. He's got a lot of experience with oil spills, shipwrecks, abandoned vessels, marine debris, and other emergency response efforts. And there's a little more information if you want on the bios and the pamphlets.
Okay, thank you. So I'm going to give you a quick overview from my perspective of lessons learned from Deepwater Horizon. Now, it's hard to spill a couple 100 million gallons of oil and not have a few lessons learned. I think that there's volumes of reports and lessons learned. I'm going to focus on the role that my office played, which was on the emergency support to the Coast Guard and in the Senate Support Coordinator role. So I'm going to go back just a step. This is the Argo merchant off the coast of New England that spilled. One of the lessons learned is that we learn lessons and we also relearn lessons. Argo merchant was one of the first big spills in the United States. Some of the lessons learned we learned from Deepwater we had already learned from Argo merchant. There's basically been a trend of a big spill about every decade, a mega spill about every 20 years in the United States. So what happens is that you learn lessons, but then there's turnover and people forget those lessons. The people that worked on the Exxon Valdez are mostly retired by the time the Deepwater Horizon happened. So one of the lessons learned is that big spills, there are no good outcomes. Argo merchant, close to it was 8 million gallons of oil that was spilled, none of it was recovered. So this is a complete loss, very little recovery. Some people, when I talk to people about my job, they think, oh, what do you do? Because there aren't many big spills that happen. Well, there are a lot of big spills. The fact that people don't hear about them is maybe a problem. But this is big spills since the Santa Barbara incident in the United States. The metric here is anything over 10,000 barrels. So that's 420,000 gallons. That's a pretty substantial spill. There's a lot of smaller spills that have lots of environmental impacts. So this is just the biggest spills in the United States. You can see up in the Great Lakes region, there aren't a lot of incidents there. There are a lot of small spills, but fortunately the region's been spared from big spills. One of the lessons learned at spills is that prevention's best. Once you spill oil, like I said, there's no good outcomes. This is a tanker that ran aground, hit an obstruction in the Gulf of Mexico, tore a 30-foot hole in the side of the tanker. You could pretty much drive a car through that hole. Didn't spill a drop of oil because it was a double tanker. So prevention efforts after the Oil Pollution Act of 1990 are a big deal. There's still about 8,000 gallon or 8,000 incidents a year in the United States. My office gets called on the more complicated ones. We respond to 150 to 200 spills a year. So that's 2 or 3 a week that we're called on. Most of them you never hear about unless you're paying attention in your region. This is just a snapshot of some of the incidents that my office has been involved with over the last 30 or so years. And you can see there are a lot in the Great Lakes region. Again, these are a lot of smaller incidents. They might be chemical spills, might be a tugboat that sinks and spills a few thousand gallons of diesel. So there is a lot of experience in the Great Lakes, just that they've been spared from those large incidents. So one of the lessons learned is that science is really important to helping solve spill response problems. I like the headline, How Science Stopped the Gulf of Mexico Oil Spill. So it was kind of handy that at that time the head of the Department of Energy was a Nobel laureate PhD in physics. So there was a lot of science that was brought to bear, not just to NOAA, but all the agencies. One of the things that I want to point out is that crisis science is a different kind of type of science. There's a lot of science that happens after a spill. There could be science to understand why did the well fail? Why did the prevention mechanisms not work? There's science on how do we, just understanding general effects of oil on the environment. There's also natural resource damage science. That's how much money does the spiller have to pay to compensate the public? And then there's this emergency response science we need to answer today because tomorrow we're going to go out and try something and we need to have some back of the envelope science to help us with that. I'm going to focus on that. Now, all of these things, you think you spill hundreds of millions of gallons and the impacts would be obvious. But a lot of times the impacts are subtle. So if you're a scientist and you're planning a study after a spill, you're not going to see big fish kills, you're not going to see immediate death of vegetation and those kinds of things. You're going to see more subtle impacts. This thing about the tuna. Now, what happened with the tuna is that the studies showed that they actually had some heart defects. It didn't kill the larval tuna, but those tuna, when they grow up, aren't going to be able to swim very fast. They're going to be consumed. That's an injury, but it was a subtle injury that you wouldn't detect if you just did an exposure in a lab. So that's a quick. Another big thing is data science. There's hundreds of thousands of samples collected. Managing that data in that science is a huge effort. So I'm going to focus mostly on this emergency response science. Is it needed? Do we need to know this for the operations we're doing today, tomorrow, next week? If it's science that's going to help us with the next spill, that puts it into a different kind of category. Mike shared the kind of key questions that we go through with what happened, where could it go, those kinds of things. And some of the lessons learned is what happened. Usually the information we get is wrong. Initial reports are often wildly inaccurate. Where can the oil go? Well, it can go very quickly. It can spread much more rapidly than the response can track it. It has multiple effects, not just natural resources, but economic and social dimensions. The impact can be very subtle, but also be very widespread. What can be done to help? Well, one of the negative sides of spill response is that often there's not that much you can do to recover oil once you've spilled it. And then when you do take response actions, they have trade-offs. How much is spilling? Deepwater Horizon, remember what the first estimates were, 1,000 barrels a day? Yeah. We got pulled in early on to help with this issue. We don't normally show up in Rolling Stone magazine, but this picture was in Rolling Stone magazine. This is day 2 of our command post in Seattle, and we estimated 64,000 to 110,000 barrels a day. That's about 2 million gallons, 3 million gallons a day was what we were working on in our war room in Seattle, even though the reports in the press were that it was 1,000 barrels a day. In the end, 3 years later, litigation, the actual estimate came out pretty close to what we had figured out early on during the first couple of days of the spill. Remember that the first estimates are going to be pretty wrong, and when in doubt, assume that it's a lot bigger than it is. Another issue that I want to point out is a lot of the outcome of Deepwater Horizon, if you look at the amount that evaporated or dissolved, 25% of the oil we think evaporated or dissolved. It wasn't a response action, it was a natural phenomenon because it was a light oil. If you look at the amount that was mechanically recovered skim, 3%. So that's about what we got in Exxon Valdez. Not a big chunk of oil is actually mechanically recovered after a big spill. That's a very difficult thing to do. So don't get your hopes up that mechanical recovery is going to solve your concerns in the Great Lakes. Another thing that we learned is that we do trajectory modeling. One of the big things we do is forecast where the oil is going to go. It can be very complicated. And these products are typically not handed out in a public forum, but in the Deepwater Horizon, these became an outreach tool. We had to be much more precise about how to communicate what our predictions are. Just like predicting weather forecast is not simple, predicting an oil forecast is not simple either. Where it's going to go in the long run, so those forecasts were where it's going to go in the next couple of days. Now, where it's going to go in 90 or 100 days. Remember, some of the early forecasts of Deepwater Horizon is that was going to go around, hit Florida, go up the East Coast, hit Scotland, and keep on going. And we knew that that wasn't going to happen, but how to communicate what was much more likely to happen was a challenge. Resources at risk. What's going to be affected if there's a spill? We know that there's what we call environmental sensitivity index maps in the Great Lakes. Those are, for the most part, quite old. They're 20 plus years old, so predicting resources at risk is going to be a challenge. Remote sensing, we did a lot of work on that, and I'll wrap up here just in a second. A lot of overflight work, again, a lot of effort to track the oil, where it's going to go, and how to get ahead of it. Shoreline assessment, a big lesson learned is that the oil that's not recovered, that doesn't evaporate or disperse, is going to hit someone's shoreline. Deepwater Horizon was the largest in terms of shoreline impacts in the United States anyways, in terms of the effort it took to quantify how many miles of shoreline, and that quantification isn't just a trivial thing, that's what goes into deciding where to send research or where to send responders to go do the cleanup. The last thing we'll wrap up is outreach. We do a lot of work on talking about spills, but the public still doesn't really understand what we do. We're taking a much bigger effort to look at how to communicate basic spill response technologies in a very simple way to the public so they understand what is a boom, what is dispersants, what are burning. Same with the shoreline. What are the options that we have? And then finally, I want to talk about recovery just for a second. Recovery, this is Exxon Valdez. Recovery is a long-term prospect, and recovery is going to depend on which species you care about and what kind of sensitivity those species have. You can see from this graphic that 30 years later, Exxon Valdez, there are still species that haven't recovered from that spill. Some things recovered pretty rapidly, but some of the big species that are pretty charismatic, like killer whales and seabirds, some seabird populations have not yet recovered. So think about that in your big picture planning for Great Lakes. So that's a quick overview. Thanks.